Hello, hello. This is Postgres FM. I'm Nikolai from Postgres AI, and as usual, my co-host is Michael from PG Mustard. Hi, Michael. How are you doing?
Hello, Nikolai. I am good, thank you. How are you?
I'm very good. So, our topic today, we are going to discuss denormalization, but at very maybe high level and basics and the pros and cons of having it used, applied as methodology. So we already had a couple of episodes. We discussed materialized use. It's a very close topic to this one. What else? We discussed schema design.
Yeah, we called it data model trade-offs. I'll link up those two. Yeah, I think data model trade-offs was probably the closest to this because naturally it came up as a big topic. And then the third one that it came up in was I had a good chat with Marcus Winand, and he made some great points around normalization and denormalization, or at least normalization. I'll link that up as well. Maybe I need to re-listen to that one.
It was my choice for this week, and I'm just thinking that it's important to get back to this topic at some maybe slightly different angles, because I keep seeing issues with these and cases of these, and I have two different customers which have consulting contracts with Postgres AI, and I just observed the need of denormalization, or at least to consider to apply denormalization to solve some performance issues, right? But before we discuss performance and reasons, let me say this. If you don't understand normalization, don't use denormalization. You need first to learn normalization and feel it and use it, right? Because otherwise, with relational databases, it can be tricky to understand the particular cases and limitations and consequences of applying denormalization. I'm not talking about non-relational databases, but we can maybe mention the work by Stormbreaker in EDB blog, discussing that MongoDB particularly, or maybe DynamoDB there as well, I don't remember exactly, the problems which happen to MongoDB, I think, document databases and big JSONs, and the tendency to have denormalized state designed by default normally, and issues later, both flexibility and performance-wise.
Was that the blog post with Alvaro?
Yeah, but yeah. So it also had the word harmful, which I inherited, and then got big backlash on my subtransactions related blog post on Hacker News. Yeah, so let's keep that aside and consider we talk about only Postgres and maybe slightly wider relational databases. First thing you need to understand is normalization, normal forms, at least 3-4 Boy's code, right? Normal form of them. Functional dependencies. It's a very interesting thing to understand. It's not only theory, because it's it feels theory and always felt like theory to me. But when you design your schema, if you understand these things, you learned it, studied them, you will feel much better thinking how to design schema, tables and columns and foreign keys between them, right?
Yeah, but and in the world, at least in the last 3 to 5 years, I think the vast majority of systems I've come across have had pretty good understandings of normalization and have got pretty good hygiene in that area from the things I've come across. I think it's one of those database things that back-end engineers, full-stack engineers generally do look up on. They do know it's important, and they do some thinking and upfront design work, get second opinions and things. So I actually I have come across some cases of, is it EAV, entity attribute value, nonsense or just things that haven't been fully thought through, but they've been really rare compared to people that have done things pretty well from the start.
EAV is radical normalization, right? Which leads to bad performance, usually. Yeah, okay. That's a good point. But I think many backend engineers look at this topic, normalization versus denormalization in general, using lens of ORM. Right, they have different terminology even, right? Sometimes hard to understand each other talking. And Also, I think today most powerful LLMs, they do a great job designing, suggesting design. For example, we integrated and it produces mermaid diagrams. So if you ask to design, I don't know, like Twitter-like or Facebook-like, YouTube-like schema or e-commerce, and then you iterate, adding tables, it generally tries to be like, to apply common sense in terms of normalization as well.
Mm-hmm. That makes sense.
But again, before starting to use the normalization, it's good to understand normalization first several forms. Then, first thing when you let's say sometimes it's convenience to have a denormalization. I maybe cannot think about particular case right now, but it happens. I know it happens. Sometimes you just think there is functional dependency here, right? But I don't go and normalize and move this data to separate table, for example, because I know, for example, this functional dependency might vanish in the future. It might change. I just know my field, and this functional dependency is only for now. It feels so, but it might change. In this case, it might be beneficial and providing more flexibility if you don't apply next step of normalization in this situation. It sounds abstract, and I cannot imagine some.
I think of one example. Like,
Yeah.
imagine if you're an early stage startup without product market fit, and you're adding features quite quickly. And like a simple example would be you're a blogging platform, and you think the idea of adding tags would be a good idea. So instead of adding a whole extra schema around that, you could have a single column where you let people add a few tags, and that might not be how you want it to be eventually, but you also might remove that feature in a couple of weeks if people hate it or something. So like you might, for convenience, go with one. Well, you don't like that?
Well, this particular case, I remember my talk in Maryland 2008, the first time I came to the US to speak how good Postgres is for Web 2.0. Mm-hmm. How many years? It's like 16 years, right? And this was was my example, tags. And I talked about HStore, or today we can talk about array. And back to that time, there was no Gin at all. So Gin was not created yet, and we used only Gist and HStore or L3 in some cases, depends. But in the case of tags, it's natural to think, okay, I'm going to put these two different table, and then you need additional table, like to have many-to-many relationship.
Yep.
And this is AEAV, exactly. This is what is going to have bad performance if you have a lot of entries in the main table, or like your objects, and also a lot of tags and a lot of relationships between them. It's really, this join can be problematic sometimes. But we will probably return to this schema, like three-table schema, later. What I wanted to just emphasize, I cannot just not to comment here. It's about performance. I would these days consider arrays with tags, or maybe arrays with IDs. We know foreign keys don't support this, like one row and you have tag IDs, right? And then like multiple foreign keys to different entries in the text table. But we can live without the foreign key here. For the sake of having good performance, we can just have these IDs or just tags as is, like text array, right? So integer 8 array, big int array, or text array. In this case, using Gin should be good.
Or JSONB.
JSONB, I feel, would add like additional layer of something here, which we don't really need, because we just need IDs or bunch of phrases, texts, or like text, right? So I don't know. Do you think this is denormalization?
I think strictly speaking, yeah.
Well, let's not say we are breaking first normal form here, because of course first normal form is like it's just saying that in each cell, basically, of a table, if you like, in each value should be atomic, right? It should not be a table, for example, or in this case array or JSON. We are breaking it, and
Yeah.
Yeah, so it's strictly speaking. But at this sense, if we consider, in this case, every time we use array, we are already breaking normal form. But at what sense it's denormalization? We are repeating. If we are repeating values, if, for example, later we found a typo in some tag and going to adjust it, this is functional dependency, of course, right? And we will need to update a lot of rows here. Of course, it's better to store IDs and have tag values in a separate table, right? So in this case, and we can even join in an interesting way, maybe with lateral join or unnest here, like it's interesting, but it's a separate topic. So if we don't store values of text, I don't see the normalization aspect here, right? It's just, we treat the first normal form in interesting way. This discussion happened 20 years ago, I think. I remember some from Chris Date, right? From some works, like, are we breaking the first normal form in such cases or no? But if we store just IDs, well, it's quite well normalized, and we don't have a EAV, so we can use Gene, search much faster. If we need some tags, we like this query is going to be much more efficient, in my opinion. But we lack foreign key, unfortunately. This is what we lose in such approach, right? Mm-hmm. So flexibility is one thing. Different thing, and this is most interesting, of course, performance. We already started discussing performance. I would highlight two particular cases. This is exactly two particular customers I observed over the last couple of weeks, two particular situations. Let's start from maybe simpler one. It's slow count, right? Did we have episode about it? I'm sure
I think we did, yeah.
Yeah. So slow count, or in broader view, slow aggregates, right? So there are approaches to solve it using like index-only scan. We also had an episode. I think we're covering more and more things, which is great. But if we see that it's not enough, what else? We need to start denormalizing in some form. And obviously we could use materialized view, which has all the counts, but it's very asynchronous. And
like pre-calculated.
Yeah, pre-calculated. You cannot do it often. You cannot. For example, we have a huge table, like 10 billion rows, for example, and we insert one more row, and we say, okay, our materialized view is just create materialized view, blah blah blah, name as select count star from the table. Interesting, right? Is it a good idea to do it often? Well, maybe no. We should do it not often. In this case, it will be lagging and showing not relevant information, like kind of eventual consistency. Yes, we will reflect next insert, unless it's got deleted, right? But it will be lagging, and some people can notice it, not good. So what else? Like, we can consider synchronous. And also, like, when you refresh materialized view, it's scanning everything. Like, it could skip some old data, understanding it hasn't changed, and just count the like only fresh part of the table. Maybe we have partitioning there, I don't know. But Postgres doesn't support this, only additional extensions like PG, IVM, or what was the name of different extension? I forgot. I just found it recently.
The one you just mentioned, was it dnorm?
Yeah, dnorm. It was interesting because I think it's Python and external to Postgres, because PG, IVM, it's an extension, so obviously you don't have it on many managed Postgres offerings. But if it's external, or for example you implement it yourself, it's quite possible using maybe triggers or something, maybe some queue mechanism involved externally to make it asynchronous and incrementally updated. In this case, it can be good and maybe more like resilient, like updating more faster and having more actual data, right? So the problem is, like, with materialized view, the problem is it's heavy. It's very rough and heavy tool. In most cases, I deal with them. I say, let's try to avoid them, get rid of them, right? in this case particularly as well. By the way, we could build also our own like kind of materialization mechanism using logical decoding, right? Logical replication even. For example, accumulating some events through... It can be also external queue mechanism, but also using logical replication. If you batch and then update, not on each insert, but after like 100 inserts or updates and so on, deletes also. And then you reflect this change and nothing is lost because it's quite Postgres-centric approach, right? Because Postgres guarantees nothing is lost. What do you think?
I like it. I remember reading a good blog post by Timescale on how continuous aggregates work, and I remember thinking I wouldn't want to implement that myself. Like I remember thinking keeping it synchronous or like synchronous enough, like it's just quite painful.
Yeah.
So I do admire people that have done that, and yeah, I can see the argument for it, but I think at this point, if once you're considering that, you probably also should be considering the synchronous approaches like triggers or some other way of keeping things just actually in sync.
Yeah, well, I agree, and I like this. I have a sense of like lack of some additional materiality mechanism in Postgres which is not yet developed, which could support some kind of asynchronous way to update things.
Oh, I'd love it if it was in core. That would be amazing.
Yeah, in core, exactly. This would be great, but it's maybe a hard task to have.
And also not that high up the priority list for most people, I think.
Yeah, but it would give a lot of interesting things, interesting capabilities to develop interesting, well-performant and responsive. I mean, not responsive, but the data is coming and you reflect it like within a few seconds. It's great. Yeah.
By the way, when you mentioned performance, I looked up the definition of denormalization on Wikipedia, and it said denormalization is a strategy on a previously normalized database to increase performance. So
right.
They're explicitly saying that the reason.
Right, but we can assume that in our head sometimes we normalize and then we move back and denormalize and then go like deploy it right away in production. This would
I thought obviously there's an interesting part there that says it has to be previously normalized, but I thought it was also interesting that the only reason they gave was for performance reasons.
Well, maybe I'm wrong thinking it can be not only for performance reasons. Of course, in my experience, I did it for performance reasons. Let's be honest. Let's be honest here. I just wanted to cover maybe cases which can happen. Yeah.
You mentioned a couple of cases that come up recently.
Yeah. Well, before we moving to the next one.
Okay. Yeah.
I wanted to emphasize if we think about, okay, we are not going to use materialized view. What else? We have a table, we insert, but we need the count very fast. Imagine we have a trigger and we update that count on each insert, or update, or delete.
Yeah,
update
and delete. Yeah,
delete. Update maybe no, depending, of course. If you have soft delete approach, then you need to reflect updates because they might be doing soft deletion, right?
Well, and if it's only a count, yeah, sure, but if it's a different kind of aggregate, then you might have to worry about
averages, sum, and so on. Yeah, min max. Min max probably is fast enough, thanks to English anyway. Yeah. By the way, of course, there are ongoing discussions about having column store in Postgres all the time, which might be good here, but maybe not. It depends on the particular case, because if your main part of data needs to be row store, you still need to deal with some replication inside your engine or outside of your engine. So replication means like maybe it's triggers, maybe it's logical replication involved, who knows. But it can be interesting. But again, we have a main table and trigger, which on each insert, it increments this counter on this additional table. Mm-hmm. What do you think will happen? Is it good?
Like hotspots. We've talked,
hotspots.
At sufficient scale. And I guess all of this is only relevant at sufficient scale, isn't it?
Yeah. So this synchronous approach can be super dangerous because heavy locking, And even without heavy locks, if we have foreign keys, for example, there, and yeah, it's going to have multi-exact ID involved, and even selects can downgrade.
But I think you can spread out. You can spread out the hotspot. Like you don't have to have a single record that gets updated. You could have a series, and that series could grow as your concurrency grows.
Right. That's like batches in place, right? And then you just sum all of it, and this is your total count, right? That's good. Yeah. This is actually what we did a few times. We just had batches. Yeah, and I don't remember particularly how. Like basically some like kind of small, kind of partitioning of your account inside one table, right? You partition those counts into like buckets or batches, how to say. And then you increment them, sometimes collapsing maybe, and so on. Yeah. Also, vacuum is an issue here if you update that table very often, and one row can be super heavy in terms of real disk space because of that tuples, right?
Yeah.
So Postgres MVCC is not good in this particular case.
Well, I think you'd ideally be aiming for those to be hot. Like, there's no reason, I think, to index that column. So I think you'd be aiming for those to be hot updates.
Good point. Yeah, good point.
And then hopefully you avoid vacuum issues at all. Yeah.
It's great, like indexless table. Yeah, actually. This is maybe the case when primary key is definitely against our goals, good performance, against
We're not
good
updating the primary key anyway. But yeah, I understand.
Yeah, I mean, this is a concept from theory as well. At the same time, when we learn like relational theory, normalization, we also learn that tables without primary keys, basically, it's also breaking rules, right? So in this particular case, we don't want primary key. It's interesting.
Isn't there like a saying, something like, first you have to learn all the rules, so then you know how and when it's safe to break them?
Yeah. Well, the whole generalization idea, you need to learn how to do it right and then how to break it right to have good performance. So we don't have a lot of time, so let's discuss this like most interesting maybe case. Back to AV maybe, but not particularly. In my projects, I did it several times. Imagine you have social media, for example. You have a lot of users, say a few million users, and you have a lot of objects, say dozens of millions of objects. It can be posts or comments, anything. Maybe it's not only like posts. There is also some concept like kind of blog organization or some data source where posts exist, right? And people can relate to those channels, right? Channels. So let's say channels. And for example, they can subscribe, or they can have permissions to view them or not to view them. It's different things. So, and then you just need to display the freshest 100 entries, posts or something, right?
Relevant to them.
Relevant to this person, yeah, only from subscriptions.
Yeah.
Or only that data which is allowed to view, to access, to edit, or anything. Or even worse, if you want to show 100 last updated or last accessed, last changed. So different kinds of timestamps can happen here. And it's interesting because some timestamps belong to the objects itself for posts, for example, creation time or modification time. But some of timestamps can belong to this particular relationship between users and those channels or posts themselves. For example, last accessed, right? It's definitely for each person, it's different in respect to particular post, right? One user accessed at one day, another user same day but different time, right? So timestamp is different. So this particular task is very common. This is common pattern. Not pattern maybe should be applied to solutions, right? But usually people just do selects, joins, and that's it. And at some point, performance become terrible. It happened first in one of my social medias, and I was super upset. I thought it's really similar to graph issues, like working with graphs, like for example, return first circle of connections, second circle of connections, and try to find some connections like in LinkedIn, right? I remember many years ago we were trying to solve it in relational database. It's quite quite difficult. We didn't have recursive CTE at the time and lateral joins and so on. So it's hard problem to solve. And query has several joins and filtering, order by, right? But some filters columns exist in one column, in one table. Different columns exist in different table. When filters and order by are in different columns, in different tables, it means you cannot have the ideal situation, a single index scan or even index-only scan, which is very good, right? And then you need to rely on one of three join algorithms Postgres implements, and I can assure you there will be edge cases where statistics and planner, they don't have idea how to execute this. So this will have bad performance.
It's the age-old issue of which is more selective. Like, is the planner going to be better off going through an index on the order by until it finds enough posts or whatever the example is to satisfy the limit, or is it going to be cheaper to look at all posts that satisfy the other conditions and then order those, if assuming they're a smaller set? And unless the statistics are good, then you could end up doing the wrong one, the more expensive one, and have a very slow query if it's a huge index.
Exactly. Imagine we order by creation time, and we just subscribe to channels. Channels have posts, so we have users table, we join with channels, we have subscriptions and posts, and then we order by creation time of posts and limit 100, right? Order by desk, order by creation at desk, limit 100. So in this case, indeed, as you say, Postgres need to choose what to do. Like, is it a good idea to extract all subscriptions and then in memory order by and find 100, or it's better to use index on created at, go backwards on this index and try to find posts which can be displayed for this particular user, meaning that they are among subscriptions. Actually, both paths are bad. They might be good in some cases, but they will be at larger scale. There will definitely be cases where these both paths performing really bad, dealing with a lot of buffer operations and bad timing, right? Execution timing. So how would you solve this particular problem? What's the solution? Yeah. Well, denormalization is one of the ways, right?
So like storing a duplicate of this data in like a materialized view. Is that what you're saying?
Yeah, for example, we take creation time and we just propagate it to the, for example, if it's a relationship to particular items, posts, we can just propagate to this table which represents this relationship. And then we can even have ideal situation, single index scan. Not index only scan, because we usually need to join data and bring actual data from like, maybe it's not in the index, but it might be index only scan for this particular table, right, which has a relationship. This is one of the ways. Of course, if we have channels, well, it's more difficult, because if we order by creation of posts, not channels, right? So it's, yeah.
Yeah, I think some of these cases, like you mentioned the one where different users have different timestamps, for example, if it's like last viewed, I think that gets really complicated in terms of...
No, vice versa, I think it's good, because if we order by last access, or like, for example, last access timestamp on channel, we just deal with channels, we can propagate it to the posts themselves. Well, we cannot. Yeah, I agree with you. It really becomes complicated. So there are cases where it's really hard to apply denormalization, but there are cases where it's easy. If we forget about channels and, for example, think about relationship between users and these objects, it can be, for example, permissions, or it can be, I don't know, like last access timestamps should be stored neither in users nor in objects table. It should be stored in like table in between, right? Like many-to-many relationship. So in this case, usually, like by default, it's good. Like we just use this table, we have index, we quickly find what we need, 100 for this particular user, 100 objects that should be displayed. But if additional filtering, this is usually in real life, we need additional filtering involving data inside objects table, right? It can be, well, soft delete, for example. We mentioned soft delete. So like deleted at timestamp. If it's It's not. If it's filled, if it's not null, then this object should not be showed in this result set, right? But we can propagate when we delete. We can propagate in all entries this object has to all users, right? We can propagate to this table. Of course, it can be a lot of rows. This depends on the situation. I would not propagate it synchronously if it's more than like 1,000 rows, because delete will be super heavy. Soft delete, it's update actually, right?
Yeah.
But we know like we know if it's like limited number of users can access each object, like not more than 1,000, say, or 10,000. We can do that, or we can do it asynchronously. Again, there is some need in, like I would say there is need in not in asynchronous, not in incremental materiality, but maybe in asynchronous triggers. So, like there is in Oracle, there is Pragma Autonomous. It's not exactly the same, but yeah, sometimes. And there are folks which are using PGQ, for example, in Cloud SQL. It's available, right? One of good things about Cloud SQL is availability of PGQ, so you can implement asynchronous triggers there yourself. So if some object has update to be soft deleted, we propagate to all rows of this last accessed or last viewed or something table, right? In this case, we can have again we can have single index scan, index only scan in, but then it might be more difficult than that, right? There is another way, like it's not about denominalization, and this is how we solved it. And not only we, I know GitLab also has to-do list, and they apply the same recipe, which I think one day we will blog about. Forget about denominalization and just use huge recursive CTE with some tricks, some algorithm actually, implementing this newsfeed pattern to solve it in very interesting way. Yeah.
Is it like the skip scan recursive CTE? Like
It's not skip scan. It's like advanced skip scan. So you have
okay.
So you need to return 100 rows. You have 100 slots to fill, and then you start working with channels, filling these slots. And each time you work with next channel, you think, okay, this channel has a fresh post, for example, has an object, a fresh object, and this is the place we replace some object we keep in memory, we replace and put it to the slot, and at some point you finish and return, but it requires some effort to implement.
Yeah, I can imagine that sounds really cool. It reminds me a little bit of one of the latest features in PG Vector, where have you seen this in, I think 0.8, it added being able to continue a scan. Like if
help
it does
us.
a scan,
We checked yesterday.
Oh no! But the idea is the same, right? If you don't yet get enough results in your limit, go back and continue the scan.
It's good if you have quite like uniform database. In our case, we are speaking about PostgreSQL, for example. We have more than 1 million documents, and more than 90% of them is mailing list and in entries, emails, right? And when, for example, you ask for source category in this huge, this approach doesn't help. But still, it encounters so many mailing list entries, it cannot find source. So basically, we are considering either. I think we currently already using partial indexes there, and I'm seriously thinking we should move to separate tables because we have only limited categories, and our use cases very often we deal with only one source.
Yeah, you could maybe partition on source.
Yeah, well, yeah. Actually, it's also a good idea, maybe. Yeah. So we deviated here from original denominalization topic, and I think it's another story how to implement newsfeed better, right? Without denominalization, but with huge recursive CTE. But like my summary is that first of all, denominalization should be applied only normalization, and it can bring new performance dangers if you don't think about concurrency and various issues with Postgres and VCC, locking, lock manager, for example, and so on. So it's interesting thing, still like quite useful to consider in many cases, but yeah, it should be tested well as usual.
I think it's one of those sharp tools, right? Like sometimes advanced craftsmen need sharp tools, but be careful they're sharp.
Yeah, something like this. Agree.
Wonderful. Thanks so much, Nikolai. Catch you next week.
Sounds good. Have a good week. You too. Bye bye.
Bye.